In this video, we'll be discussing what the human body is made out of. The human body is made out of matter. Matter is any substance that has mass and takes up space by having volume. Furthermore, an atom is the smallest unit of ordinary matter that forms a chemical element. We have two examples here in this slide. We have hydrogen, which is a very simple atom. It has a single, what's called a proton in its nucleus. And we have oxygen, which is a bit more complicated. It has both protons and neutrons in its nucleus. And in both hydrogen and oxygen, we have electrons orbiting the respective nuclei of these two atoms. Moving on, we have an element. An element is a pure substance consisting of only atoms that all have the same number of protons in their nuclei. A chemical compound is any substance composed of identical molecules consisting of atoms of two or more chemical elements. An example of a chemical compound that you all know is H2O. That's water. So it's two hydrogen atoms together with one oxygen atom. Unlike chemical compounds, chemical elements can't be broken down into simpler substances by any chemical reaction. So an atom, as I mentioned, is composed of particles. It has subatomic particles. In the very center is the nucleus. This is known as the atom's central core. Within that nucleus, there are protons, which is a positively charged particle, and it has mass. There are also neutrons. These are electrically neutral and also have mass. Finally, surrounding the nucleus are electrons. These are negatively charged particles, and they have very little mass. They do have mass, but it's very small, very negligible. The electrons are found in what are called shells. These are regions surrounding the atomic nucleus that contain a specific number of electrons. So let's take a look at hydrogen. Again, it has a single proton, which is positively charged. It has 0 neutrons in general, although there are some isotopes of hydrogen that do have a proton and a neutron. There's also an electron. So you can see that this atom is electrically neutral. It has one positive charge due to the proton, and it has one negative charge due to the electron. And those, in a sense, they cancel each other out, so it's a net charge of 0. Let's take a look at oxygen. It has 8 protons in its nucleus. Those are all positively charged, so it has 8 positive charges. It has 8 neutrons. As the name implies, neutrons are particles that are electrically neutral, so they don't contribute anything to the electrical charge of the atom. And then in your typical oxygen atom, you would have 8 electrons. Those each have a charge. Each electron has a charge of -1. Therefore, the positive 8 charges are balanced perfectly by the negative 8 charges of the electrons, and therefore this atom would be electrically neutral. So let's move on. So the next thing I want to talk about is atomic number. Each element has a unique number that identifies how many protons are in one atom of that element. So for example, hydrogen has an atomic number of 1 because it has a single proton. Oxygen has 8 protons, so it has an atomic number of 8. And so these basically, for an atom to be of an element, it has to have that number of protons. So for example, if we take hydrogen and we add somehow we magically add another proton, it would have 2 protons now. It would no longer be hydrogen. It would actually be a different element called helium. Okay, finally, let's talk about atomic mass. Atomic mass is the number of protons and the number of neutrons together. And this determines the atomic mass number. So again, the atomic mass is the number of protons plus neutrons. Now, if you look it up, you'll actually find that the atomic mass is never an integer number. And the reason for this is actually fairly complex. And part of the reason has to do with the fact that there are isotopes. So I mentioned there's an isotope of hydrogen in which you have 1 proton plus 1 neutron. So that would clearly change the atomic mass a bit. So that's why when you look at the atomic mass numbers in a chart, sometimes it won't be an integer number because what they're doing is they're averaging in the fact that found on Earth there will be some isotopes of a particular element. Finally, let's talk about the periodic table. This is a way of organizing all the elements by their atomic number. So if we look at this table that I have here, we've already mentioned hydrogen. It has a single proton, so it's an atomic mass of 1. Let's look at oxygen, which is another atom we've been looking at. It has 8 protons, therefore it has an atomic number of 8. Now, so this is a very convenient way of organizing the various elements, and it actually is very helpful in that when you look at a column within the periodic table, within a column there are certainly different elements, but each element has some similarities. So if we look at hydrogen, it typically has a single electron in its shell. It's an outer shell. It only has one shell, so its outer shell is very simple and has a single electron there. If you go to lithium, well, it also has a single electron in the outer shell. And if you go to sodium, it has a single electron in the outer shell. The same thing with potassium and so on. So, and it turns out these electrons are very important for the chemical properties of an element. And that's something we'll discuss in the next video.